Okay, so you've exported the data from your Pascal program, SparkView, and I didn't get a chance to show you how to import the data. So if I'm using Excel, which I have currently open on the screen, you're going to have the exported file, this data file that you either emailed it to yourself or it was messaged to you or something. For me, my CSV file, it defaults to Excel. Excel is what opens it up. So I can just double click on it and it'll open up in Excel. But if you don't have it defaulted, then you're going to go to File, Open, browse to wherever you saved the file. So for me, it was in Downloads. And it says All Excel Files. So I'm going to change that from All Excel Files to All Files. And then that will show me the exported data. So it depends on whether or not you have CSV files associated with Excel. Now, once it's in here, you have a lot of data. It happens that the group that I'm using, they changed their recording at some point. They did change the recording from measuring 10 times a second to, I think, once a second or twice a second. So they don't have as much data for a lot of their runs. I think their first run, they must not have changed it because there's quite a bit of data in here. And then the next thing you want to do is you want to look at the runs. So I'm just going to highlight all these. Just double click on the side here so I can see the titles. And so I, as a group member, I know that run number 1 is pH 2, or run number 1 is 21 degrees, or run number 1 is 1 molar silver nitrate. And so you have to put that information up in this title. You don't need these dates. So these date fields, see, I'm going to click on the A, and click on the D, and the G, and the J, and the M, and the P, and I'm going to right click and delete. So that gets rid of all those date files, because I don't need them. For my time, well, because this first run here, see how it's a different time? 0, 0.05, 0.1, but all the rest of them are all the same time, 0, 1, 2, 3, 4. So it means that this first run here, I can't graph on the same graph as the rest. And I know this group, they had this, they redid this run, so I can delete run number 1 because it's not important information. So I'm going to delete that. So it leaves me with run 2, 3, 4, 5, and 6. So I'm not sure what was what. So I'm just going to make up these values. I'm going to say that run 2 was the pH, let's say it's temperature. Metal salts, let's say it's metal salts. So let's say that this is 1 molar silver nitrate. Same, copy, paste. So that's the time. Sorry, for pressure, 1 molar silver nitrate. Hit spell. And then this one here, let's say it's 0.1 molar silver nitrate. And run number 4, let's say it's 1 molar copper sulfate. And run number 5, let's say it's 0.1 molar copper sulfate. I'm guessing number 5 run is a dead run because it only went for 30 seconds. So I'll just delete that. And let's say this one here is 0.1 molar copper sulfate. So I have all the data. And you have to determine what the runs are. You have to tell everybody. You have to put that in there. So once you have this data in here, you could save it. So I'm going to save this. File, Save As. I'm going to change it from CSV to Excel. I'm going to type in the name. So I'm going to say metal salts. I'm going to say erase me. So now it's saved. So then I'm going to go into the folder. So if I go to the Google Classroom and I have the Enzyme Lab Share Data folder, and then I'm going to click on View Material, and it's going to open up this Google folder. Right. So I'm going to go and get the data that I have here. metal salts. I'm just going to drag it over and drop it in. And now anybody in the class can access that data, right? And I've changed the data in such a way that I can, or anybody can see what each run represents. If you don't change the run numbers, you leave it as run 1, run 2, run 3, then the data is useless. We can't use it at all. Okay, so there's the data they uploaded. Now, when it comes time to actually graph the data, in case you're confused on how you might do that, see how this time? The time is the same for every single field. So I can delete my time runs for runs 3, 4, 5, 6, whatever. So I'm going to delete those. So now I just have data. I have the time run. This is my X, and then these are my Y values. So I'm just going to highlight all these. I'm going to click on Insert. I'm going to go to Chart. You want Scatter Plot. You can do it with a line or without a line. I'm going to do it without a line. And it inserts my graph. Now, you'll notice my X-axis, my Y-axis, they are automatically assigned. So this value here, starting at 100, this value here is at 0. From 0 to 100, there's nothing. So I'm going to want to change those minimum values so that it has a better representation of the data. So as opposed to starting at 0, I might start at 95. If I do that, then I get a much better representation of the data. Instead of ending at 160, I might end at 145. If you got data and like the last 5-10 seconds weren't very good, then instead of going up to 120, I can go to, or 140, I can go to 110. You just want to be consistent. And instead of starting at -10, yeah, I want to start at, let's say, 10 seconds. So there I can look at my data and I can see exactly how my data compares with each run. I can clearly see the blue has more activity, then the orange, then the gray, then the yellow has no activity whatsoever. So this is a good representation that you'd use. You change the chart title, then you copy this chart, put it into your Word document or into your whatever document you're writing things in, and there's your graph. So remember, if you want to get the highest mark possible, then you have to actually create your own graphs. If you are one of those students who have 1,000 data points, it's still okay. It just is going to put a lot of pressure on your computer to perform because it has to deal with all that data. But this is really simple text data, so your computer should be okay. Someone asked if you're able to go in and just take up a sample point for once every second. You could do that, but that would take forever, and it's not really necessary. Just know the next time that we collect data that you can change the periodic sampling rate from the default to once or twice a second, and that should be plenty for a pressure experiment like this. Okay, so hopefully that gives you an explanation of how to take in your data, how to change your data, how to save it, how to put it into the Google Classroom for everyone to use, and then also how to create your own graphs. All right, if you're not happy with the data that's put up, you can always use the data that's in the classroom environment. So if I go here to content, you'll probably go to calendar. Actually, it's probably easier for you to find it like that. And go to the Enzyme lab, click on more. And here you'll see a bunch of things, including a template that you can use to create your lab with. You don't have to use it, but it gives you an alignment with the lab instructions. I would expect a lab to be communicated in the correct form. You'll also see results from other years, from quite a few years. I put like a decade's worth of data, so you can use all this data if you'd like. But in the Enzyme lab template, at the back end of it, let's scroll down here, I also dumped some data. So this data here is low-tech data. So if you want to use low-tech data, which is collected using a gas collection tube and measuring the volume of water displaced once every 30 seconds, you can use that. And then there's several forms of that data. So this data is something you can compare it against, but it's not the high-tech data that you used. If you want to use the high-tech data, then you're going to have to go into some of these other zip files or other sample places. But generally the best data to use is our class data. I did vet it. I took a look at what everyone was doing in class, and it looked like you had good data. So hopefully everyone in the class gets their data up. Again, morning or afternoon data is perfectly fine. We're all one big giant class, so you can use whatever you'd like. Okay? When you're doing the enzyme lab and you're writing it up, you'll notice that there's different levels depending on what you complete. If you're trying to get the highest level, then what you're going to want to do is you're going to want to make sure that you have all the parts, substrate concentration, enzyme concentration, pH, temperature, metal salts, all that completed. And if you're not aiming for the highest level, so let's say you're aiming for a lower level, maybe you're in level 4, like an 85, then you don't have to analyze every single part A through E. For the background, do not copy and paste this background I've given you. I've given you some background, you need to make up your own. The hypothesis you have already completed, but you need to resubmit in the final lab. If you want to, doctor it up a bit and finesse it, make it look neater and all that kind of stuff, you're welcome to. But for the most part, I'm going to mark your hypothesis from your original submission. If you didn't submit your original hypothesis, I will not mark your hypothesis. In the procedure, you do not rewrite the procedure because it has already been done for you. The only thing that you're going to do is record anything that's special for our lab or any changes. So for example, the mass, I used 30 grams per 200 milliliters for day 1 and 35 grams per 200 milliliters for day 2 of liver. And if you did anything special in your lab that isn't on the instructions, that's where you put it. But do not repeat the entire instructions. For observations, only put down what you observed. So everyone that was observed part A, and then I assigned an individual part for B, C, D, and E to the groups. So for the observations, even if you're aiming for the highest level, you only put down your observations. If you were not here for the second day, that means you did not do it, and you can't put down that second part of observations. For the analysis, so let's say you are doing the analysis for the entire lab, part A through E. Well then, you need to include the observations for what you did not do in the appendix. Okay? And when I talk about the observations, do not put in a chart with 1,000 data points. That's way too much information. If you want to put in a sample chart, that would be fine. Or if you even want to put in that sample graph as an observational graph, then that's fine. But do not put in a chart with 1,000 data points. That's just way too much information. For the analysis, if you're only analyzing, 2 or 3 parts, then that's fine. You can't get the highest level, but that's still good. It could get you a level 4 potentially. But if you are going for the highest level, then you are analyzing the part A, part B, part C, part D, and part E. In the analysis, this is where you have the graph. So you've taken the data and you've created a graph from it. You should also explain what the graph is about. You're not interpreting the graph, you're stating that, oh, with increasing temperature, it's going faster, or something really simple. In the analysis, you can also have a special graph where you take data from the various graphs and put it together. Our class, morning class, did complete an extra experiment where they're comparing the beef, the calf, and chicken liver against each other. So that's another data point that you can include. Interpretation includes several parts: your sources of error, analysis of investigation, strengths and weaknesses. In some cases, those are very similar, so you might do one or the other. But the most important part of the entire lab, the one that really determines whether or not you can get a level 3 or level 4 or high level 4, is the theory. This is where you connect to the content, the biochemistry, the metabolism. This is where you talk about kinetic molecular theory, the particle theory, the fact that the protein denatures and doesn't work anymore, competitive inhibition, denaturation, all that stuff goes in here. And I'll be looking to see that you're using the appropriate language and that you're connecting it to our content and that you've done additional research. These are guiding questions. You can use these to kind of help you to have a very thorough um, interpretation section. Do not do a question and answer. Question and answer is more grade 9, elementary school. When you get to high school, especially grade 12, you have paragraphs that explain what's going on. So you can use these here to help you with your interpretation. You do not answer the red as a separate section. It goes inside these experiment A, B, C, D, E, and the optional F. Evaluation, revisit, strengths and limitations. I mentioned those already. Conclusion should not be very long. This lab, it might be a little bit longer because there are so many different parts. Your appendix is where you put any observations that you did not do. You can put data tables in here, but if you have really long data tables, things that are like 1,000 data points, I would say just say refer to the Google Classroom data tables and then be very specific. But you don't want to have a 500-page lab report because you have 400 pages of data, 450 pages of data. That doesn't make any sense. Okay, not for us anyway. You can also put any graphics in the appendix that you might find that might support your explanation of denaturation, let's say, what catalase might look like. And of course, your reference, you can use any style, APA, MLA, Vancouver, whatever is appropriate, just be consistent. And that is the lab template. So you're welcome to use this, or you can create your own. As always, you are being marked on your originality. Do not copy. We already had an incident where students have copied each other and they received a 0. Do not copy and paste from the internet. You can take a small amount of information from the internet, 10%, 20% at the most, and then reference it properly, but you should be producing original content. Absolutely do not put yourself in a position where you are going to receive a 0 from copying people's information and then passing it off as your own. You're welcome to talk to each other and make sure that things are, appropriate, that the data looks good, but you are submitting your own individual work. All right? This is going to be a part of the midterm mark, and for some of you, you're not going to be happy with the grade, and if that's the case, then you're probably going to do the plant lab as a major lab, and that will replace the enzyme lab, and then that will be on your midterm mark. In your lab notebook, I will be looking at either the enzyme lab or the plant lab as a major lab, and the other one could be a minor lab potentially. For those of you, there's quite a few of you who are absent on the second day, you're probably going to be doing the plant lab because I don't have a product observation and conversation section for you for the second day where the major part of the lab occurred. And so you could still do the enzyme lab if you wanted, but your mark would probably be deflated because I don't have that section for you. Online, some of you, I have some observation conversation. Others of you, I did not have a very good conversation with you based on your understanding of what was happening. So just be aware of that. That's just one of the dilemmas about this hybrid course that we're taking, that you're not able to really demonstrate effectively unless you're very purposeful, your understanding of the inquiry that we do in class. All right? Hopefully that explains everything you need to know about the enzyme lab. It is due on Friday before you leave for March break, and I will see you in class on Monday. Goodbye.